A very good morning to all the participants. I welcome you all to this third day of the 1 week online FDP on harnessing virtual labs for effective student engagement. So yesterday we had Mrs. Akshaya and Ms. Shrestha ma'am who have led us through the computer science, information and allied domains and how to use those virtual labs from the website. And today we have a session on circuit engineering branches and physical sciences. We have Mrs. Vismaya and obviously Mrs. Shrestha ma'am, who will be leading us throughout the sessions. They're from NIT K Virtual Labs Development and Outreach Team at Center for System Design at NIT K Surathkal. So without wasting much time, I would like to hand over the session to the team. Over to you, ma'am. Shrestha ma'am.
Yes, sir.
Yes.
Can we proceed, sir?
Yes, ma'am.
Thank you, sir. So, a very good morning to an enrolled presenter here. Myself, Shrestha, and Vismaya is also here from Virtual Labs team at NIT K Surathkal. So, we welcome you all for today's session on virtual labs, especially with the demonstrations in circuit domain concepts. So, on Virtual Labs team at NIT Surathkal, we once again welcome you all. So I think we'll be starting session now. First, the session will begin by the presentations from Vismaya. Then myself will be continuing the session. So thank you. Over to you, Vismaya.
Yeah. So good morning all. So myself Vismaya, working as a part of Virtual Lab Development and Outreach team at Center for System Design, NITK, Surathkal. So today we'll be taking you to some of the labs and experiments which are relevant to circuit domain. So we'll be selecting experiments from electronics and communication engineering domain, electrical engineering and physics. So yesterday you have heard from Akshaya regarding all the experiments which are demonstrated under computer science engineering. So without delay, I'll be stop sharing my video and I'll be starting the presentation. I hope my screen is visible and I'm clearly audible.
Yes, ma'am.
Thank you, sir. Yeah. And I hope you are all familiar with the website, that is Virtual Lab website by now. So again, just I'll be taking you to website. So this is the website, which is vlab.co.in, is the link to access to the Virtual Lab website, vlab.co.in. So as told yesterday, it's an initiative of Ministry of Education under the National Mission on Education through Information and Communication Technology. So moving down, you'll be getting all the objectives of Virtual Lab, which is mainly to provide remote access to simulation-based labs in various disciplines of science and engineering. And we call the Virtual Lab as a 3P lab. So the 3P are pace, place, and period. So based on period, there is no time restriction or no requirement of physical lab. One can be anywhere, even while traveling, he or she can use this virtual lab. Pace means speed. So some of you might be completing, or the students might be completing the given experiments within the given time, but some might not be. But here in the virtual laboratory, the user can take their own time to do the simulation from wherever they go. Again, if you move down, you'll be getting all the broad areas of virtual labs listed here. Today, we'll be demonstrating you labs and experiments available under Electronics and Communication Engineering, Electrical Engineering, and Physical Science domain. So moving down, you will be getting all the participating institute logo. So if I click on to NITK Surathkal logo, you will be getting the list of labs and experiments available or developed by NITK Surathkal. So the labs which are already hosted under the website are mainly from mechanical engineering, civil engineering, and electrical engineering. So if you go down, you will be getting substation automation and industrial electric drives lab, which is available or which are under electrical engineering domain. So going back, again, you have an outreach portal, which is listed here, and which is mainly giving you all the details of outreach activities which are conducted from all the participating institutes. So you'll be getting list of the nodal centers, users trained, workshops, usages, and so on. So you can see here almost 1,725 nodal centers are available, 13 lakhs plus users are trained, 19,000 plus workshops are conducted, and so on. Again, if you go down, you'll be getting options of nodal centers, overall usage, year-wise usage, and new nodal center. So you can check whether your institute is a part of this virtual lab project by clicking on to year, as well as you can select the state where your institute is. So once you select the state, you'll be getting the list of institutes which are part of virtual lab by signing expression of interest. Also, if you had conducted any of the outreach activities and if you had submitted it to the respective participating institute, you will be getting the number of users trained, number of workshops conducted, and the usages which are available under the outreach portal. So that's just a brief about outreach portal. Moving back to the main website. So to get the electronics and communication engineering domain labs and experiments, you have to move down to broad areas of virtual lab, select electronics and communication domain. So if you click onto the electronics and communication domain, you will be getting the list of labs and the institute who developed these labs and experiments. So today I'll be taking you to some of the experiments available under electronics and communication engineering. So first we'll go with the basic electronics lab, which is developed by IIT Kharagpur. So if I click on to that, these are the common field available for each of the lab under the website. So you will be having an introduction of the lab. So the introduction provided here is mainly of basic electronics lab, and objective of basic electronics lab is to provide hands-on experiment are integral part of engineering education, and the aim is to provide a virtual laboratory platform for UG students studying the course of basic electronics here. And this basic electronics lab have mainly experiments which are of basics like familiarization with resistors, capacitor, inductor, Ohm's law experiment, and so on. So let's select the fourth experiment, which is Ohm's law. So if I click on to this experiment or any of the experiment available under the website, these are the common field. That is, you will be having an aim of the experiment. Detailed theory will be provided. As this is Ohm's law, we have the Ohm's law stated here. And also Ohm's law or explanation of Ohm's law for resistance in series and parallel are provided under the theory part. So for more detail about Ohm's law, you can go through the theory. So next is pre-test and post-test questions, which are mainly some set of MCQ questions with 4 options. So pre-test questions will be mainly based on the theory part. So you can just click your answers and get the right and wrong answers. I'll be just selecting the random answers here. So once you click on to the right answers, it will be marked in the green color, or else if you have selected in the wrong answers, it will be marked in red color under the post-test as well as the pre-test questions. So once you complete the pre-test questions, you can move on to the procedure section. So again, you have detailed or step-by-step procedure to complete the simulation provided under the procedure part with the images. So let's start with the simulation. Again, we have different variations of Ohm's law provided here. I'll be going with the first one. Yeah. So here we have the Ohm's law experiment provided, and here we have the instruction, control section, experimental table, and an area to plot the graph. So looking onto the instruction, first we have to select the resistance value, select the DC voltage. You can drag and select this or slider. You can use the slider to select the DC voltage and the resistance values. Click add to table button. So you can see in the experimental table, the voltmeter, ammeter reading and the resistance value are noted down. Also in the circuit diagram, it will be changing. So keep the resistance value constant, take another set of DC volt, click add to table button. So you can do this, you can follow this procedure and complete the simulation. So once you get sufficient value of DC voltage and once the experimental table is updated, you can plot the graph by clicking onto the plot button. So once you click onto the plot graph or plot button, you will be getting the VI graph here. And if you need to print or if you need to save this page, just click onto the print button near the graph. So you can print it or you can save it as PDF for the future reference. Yeah. So that is the simulator interface of Ohm's law experiment. So if you need to clear all this value and take another set of value, just click onto the clear button given under the simulator. So that is a simulation of Ohm's law experiment. So once you complete the simulation, you can go to post-test questions. You can complete this post-test questions and get the right and wrong answers. So after the post-test questions, for some of the experiments, you will be getting the assignment questions. So you can go through this assignment questions and you can give this assignment questions for the students and ask them to submit this answers. And also you have the references part, for which are the resources which are used to develop this lab and experiments, and also contributors for this experiment. So if you have any query, you can directly contact this contributors. So they'll be helping you. And finally, there will be feedback. So that's all about this experiment. So next we'll move on to some of the other experiments available under electronics and communication engineering. Similarly, there are other list of experiments under basic electronics virtual laboratory. Now I have shown you one of the experiment, which is Ohm's law. Similarly, for all the basic concept, you can see this basic electronics lab, which are familiarization with resistors, capacitors, inductors, and also the diode related experiments, also BJT, common base, common emitter characteristics, and so on. So I hope this experiment, you got how to complete the simulation or how to proceed with this experiment and the lab. So now I'll be just taking you to the other labs under electronics and communication engineering. So we'll select one of the lab, which is analog and digital electronics lab under electronics and communication engineering domain, which is mainly describes about the fundamental component of electronic curriculum designed to provide students with practical hands-on experience in both analog and digital circuitry. So here in this lab, the main objective of the lab is to provide or to get practical experience in the design, assembly, and evaluation or testing of analog components and circuits, including op-amp, timer, logic gates, etc. So moving on to the list of experiments, here again we have around 9 experiments, mainly of familiarization with general breadboard, familiarization of ICs, De Morgan's theorem, decoder, and subtractor, and so on. So you can go through all the experiments available under analog and digital electronics. I'll be going with one of the experiment. So looking onto the target audience, these are mainly for whom the lab is applicable for will be provided under the target audience section. Next is course alignment or the syllabi referred in developing this lab and experiment. And finally, there will be feedback. So that's mainly this objective or introduction of this analog and digital electronics lab. Moving on to the list of experiment, I'll be selecting the second experiment, which is familiarization of ICs. So once you select any of the experiment, you can see the other field which are common. You will be having an aim of the experiment. Detailed theory of this experiment is provided, which are mainly of ICs. So here you can see the list of logic gate using gates ICs used in simulations, mainly IC 7404, which is not gate, and so on. So for all this details, you can go to the theory part, and mainly what are gate or what is logic gate, which are the different types, and which are the truth table of different logic gates, and what is integrated ICs, which is mainly semiconductor wafer on which thousands or millions of both the active and passive components as resistors, capacitors, and transistors are fabricated. So the detail about ICs, different type of ICs, different logic gates, and their our truth table and their symbol, everything is provided under the theory part in detail. So if student or if a teacher needs to explain this to student, you can use this virtual laboratory, which is familiarization of ICs, coming under electronics and communication engineering domain, and under analog and digital electronics lab 1, which is developed by IIT Roorkee. So that's about the theory. Again, you have the pre-test, post-test questions and all. So you can just get the right and wrong answers by clicking the options. Next, we'll move on to the procedure. So here, the procedure is mainly to select an IC from the list, select the or fill the truth table for the IC, select any one of the gate of the IC, and so on. So directly we'll move on to the simulation. Yeah. So this is the simulator interface of this experiment, which is familiarization of ICs. So again, I think we have to do some connections here. We have two buttons, check connection and reset option, which is not active. So here you have to select IC, the first option. So I'll go with the first one. Again, now once you select the ICs, you will be getting an option of instruction, truth table, check connection, reset button, and so on. So I have to fill the truth table output first. I'll be filling it. So I have filled the truth table here and a truth table output here. Now I had got a pop-up message stating right connection. You can start the simulation. So again, we have the instructions provided over here to complete the simulation. Components list are provided here. I have to select the gate. I'll be going with the first one. So now we have to select the components. So once you click onto the component button here, you'll be getting the list of components and select each one. So I have to select everything. Yeah. I think I have selected everything. Yeah. Okay. So once you come click onto the components list and get added this to the breadboard, you can try to connect this. So to connect this, you will be having the instruction here, and also under the procedure section, if you go to the procedure part, you will be getting the uh, procedure to connect this breadboard connection or other for the connections mainly. So for the first connection, that is for components of IC 7404 input NOT gate IC, you have the connection for gate 1 provided here. So you can see this connection table for gate 1 and start connecting. So we have to connect the pin 14 to supply VCC. So you can just drag and connect this, and I think, yeah. So again, pin 7 to supply ground. Supply 7 to ground, and also LED terminal C1 to supply ground. LED terminal C1 to supply ground. Also pin 0 to LED terminal A1. Pin 0 to LED terminal A1. And pin 01 to input 1. Yeah, so I have done the connection. Now you can see whether it is right or wrong by clicking onto the check connection button. So you got a pop-up message stating connection is successful. So just click onto the OK button, and you can, by clicking onto the toggle switch, you can verify the input and output of this NOT gate. So once you get the value as 1, output as 1, you can see the LED is glowing. So this explains one of the familiar ICs working, which is IC 7404 one input NOT gate IC. So similarly, we have other gates. You can select other gate options and see the working of this ICs. So that is simulator interface of familiarization of ICs of 7404. So if you need to reset all the connection, just click onto the reset button. So everything will be reset, and you can start again the experiment. Yeah, so after simulation, you have the pre-test as like other experiments, references section, contributors list, and a feedback. So you can just go through the experiment and see, or you can learn about the ICs mainly. So that is the experiment available under Analog and Digital Electronics Lab, which is from IIT Roorkee. Similarly, we'll go with other experiments, maybe from other labs. So let's see some of the experiment from microcontroller lab, which is embedded system design with 8051, and PIC microcontroller, which is developed by COEP Technological University, Pune. So under electronics and communication engineering and electrical engineering lab, there are many new labs hosted. So you can just go through it. Yeah. Once you select the lab, which is embedded system design with 8051 and PIC microcontroller, you can see the common topics, which are introduction, objective, list of experiments. So these are main experiments which are under this laboratory, mainly of programming for delay generation, output interfacing, on-chip timers or counters, on-chip ADC, PWM generation, of programming of PWM generation, so on. So mainly there are 5 experiments here. Next is the target audience. So this microcontroller lab is mainly applicable for UG, which are second year and third year students, or fourth semester and fifth semester and sixth semester of AC, computer science engineering, instrumentation engineering, electrical engineering, electronics and telecommunication engineering, and so on. So next is the course alignment, and finally the feedback. So moving on to the list of experiment, I'll go with the second one, which is programming of for input-output interfacing, LED and switch interfacing. Again, I repeat the same things, which are aim, detailed theory, pretest procedure, simulation, post-test, reference, and feedback. So the aim of this lab or this experiment is to write a program of LED blinking through push button using PIC18 series microcontroller. And the objective of this experiment is to demonstrate the use of PIC18 series microcontroller to control the blinking of an LED through a push button switch. And also it investigate the functionality of microcontrollers, GPIO, which is general purpose input output pins, and how they can be programmed to control the state of an LED based on the state of push button switch. So let's move on to the theory part. Yeah. So in the theory, you'll be having detailed about PIC18 series microcontroller, schematic diagram or schematic components used in simulation. For this simulation, mainly microcontroller, which is PIC18F4550, and aqua color LED, resistor of 330 ohms, and a push button is used. Again, you have the current sinking and current sourcing operations provided here. So what does a current sinking operation means? It is mainly the current flows into the device. And in this method, the button is pushed to high and LED starts blinking. And from current sourcing operations, it's mainly the current flows out of the device. And in this method, the button is pushed to low and the starts blinking. So the theory is provided. You can just go through it. Next is, let's move on to the procedure directly. So, yeah. So for this procedure, we have different steps provided. We have to select the input pin for switch, output pin for LED, switch configuration, LED configuration. We'll be getting the generate code, compile, execute button. And also we will get a mimic open on the left side of the screen where we have to connect the circuit and get the output LEDs on or not. So let's move on to the simulation. Yeah, so we got the simulator interface. So we have here a microchip PIC18F4550 provided, and the figure A and figure B of microchip is provided. And also we have some of the configurations provided to select the input pin for switch, output pin for LED, switch configuration, LED configuration. And also we have 4 more options to generate code, compile code, execute code, download a program, and so on. Okay. So if you have any doubt, you can go through the procedure, read the procedure once again, and you can complete the simulation. So first thing is we have to select the input switch here. I'll go with the first one only, R0 and RDO. And also select the switch configuration and LED configuration. So once you complete the configurations, you can just click on to the generate code. So it will be generating the code for you. And also, if you click on to the compile code, you will be getting the terminal window open below code for errors. Okay. So we got it here as program compiled successfully. So next you can execute the code. So once you execute it, you will be getting a mimic on the left side. So you have the mimic with whichever you will get it. We will be getting a square wave graph after the connection of the circuit. So here again, you have the circuit connection, but circuit connections, you have the check connection option and also a reset connection option. So once you complete the connection, you can just click onto the points, it will be connecting. For the connection, again, you can see to the procedure part, you will be having the connection of mimic also provided over here. So once you complete the connection, here you have the switch terminal, just click on to that. So before that, you have to check whether the connection is right or wrong by clicking onto the check connection button. So the connection is right. Now you can click and hold the switch. So you will be getting the output. Okay. Yeah. So if you need to download the program, you have an option here. Click onto that. So the program will be downloaded. And once the connection is completed and if you click on the switch terminal, you will be getting the square graph of voltage versus time. Okay. In the mimic. Yeah. and you can download this program. It will be downloaded to your download or desktop, whatever options you are giving. Yeah. So that's about this simulator interface, which is of programming for interfacing LED and switch configurations. So once you complete the simulation, you can move to the post test, again the references and feedback. So here in the feedback option, you can take at least, it may take you only 3 minutes, which you can provide the virtual labs feedback, so that we can make it better for you and for others. So that is one of the experiment which comes under embedded system design with 8051 and PIC microcontroller, which is under electronics and communication engineering domain. So again, moving back to the main domain, that is electronics and communication. Now let's move on to the electrical engineering domain and see some of the experiments available. So similarly, under electronics and engineering domain, you have digital electronics lab, digital logic design lab, DSP, which is digital signal processing virtual laboratory, hybrid electronics, microelectronics and VLSI engineering laboratory, and so on. You can see it later and explore other experiments available. So now I'll be taking you to some of the labs available under electrical engineering domain. And I hope you are getting the flow, how to use this experiments. So let's click on to electrical engineering domain. Yeah. So the flow is same. You will be getting the list of labs and the institute who developed these labs and experiment under electrical engineering domain. So under electrical engineering also, we have different labs which comes under, which are like analog signals, network and measurement lab, control engineering, electrical machines, and so on, which are some of the concepts are common between electrical engineering, electronics engineering, computer science engineering, physics, and so on. So now let's start with the basic lab, which is electrical machines lab developed by IIT Roorkee. So this lab is mainly giving you familiarization about the electrical machine apparatus and so on. So the objective of this lab is to mainly understand the basic concepts of electrical machines. So let's see the list of experiments. Yeah, so we have the experiments around 8 experiments, which are mainly describing about the familiarization of electrical machine laboratory apparatus and to study the load care of DC shunt generator and so on. And also the target audience mainly for BTech or BE in electrical engineering and MS or PhD beginners in electrical engineering domain. Course alignment. Mainly the syllabi are referred from Uttarakhand Technical University, Himachal Pradesh Technical University, IK Gujarat Punjab Technical University, Bhagwant University, Graphic Era University Dehradun, and DIT University Uttarakhand, and so on. So the feedback. So let's move on to the experiment. Yeah, I'll go with the first one, which is just familiarization of electrical machine laboratory apparatus. So again, I'm repeating, which is aim, detailed theory. In the theory, you'll be getting all the basic details of resistors, capacitor, inductor, voltmeter, ammeter, relay, circuit breaker, auto transformer, and so on. So for first year students and all, it will be helpful for them to learn more on electrical machine laboratory apparatus using this experiment. So let's move on to the pre-test questions. I'll be selecting some of the random answers and let's see. Yeah. So the answers are marked here. And again, moving on to the procedure section. So the procedure of this experiment is mainly to name and symbol and the function of respective equipments. You will be getting some of the machines in the boxes. You have to just drag and drop the correct items in the empty boxes. So let's see the simulation. Yeah, so we have some of the equipments provided here. So the name of the equipment is given under the symbol of the resistor is provided, and also its function is provided under each boxes for different equipments. So here you have the capacitor, inductor, and resistor, and so on. So once you click on to, after you're familiarizing these lab equipments, you can just move on to the next, where you can just drag and drop the items here. So you have to just drag from the boxes and drop it in the empty box. So once if the drag item is correct, you will be getting a pop-up message as correct. Yeah. So we have dragged all the 4 items to the boxes, empty boxes provided as named. So if you move on to the next, again, you will be getting some of the other equipments, their simple and the function. You can just familiarize it, move to the next box, next page. Again, you have to just drag and drop the items. So if the items which we dragged is wrong, you will be getting a pop-up messages. Please try again. So try, if you know the correct, you just drag and drop it in the right boxes. Yeah, and you can click onto the submit button. So you will be getting an option to print it, and you can save it as PDF for the future reference, where you will be getting the name of the equipment, images, their simple and their function. Yeah. So this is how finally you will be getting once you complete and submit the experiment. Okay. So that is the familiarization of electrical machine laboratory apparatus simulation. Similarly, you have the pre-test questions, references, contributors list, and a feedback. Yeah. So now next move on to some other lab and experiment. So I was taking you to electrical machines lab developed by IIT Roorkee for this familiarization of electrical machine apparatus experiments. Now let's see some of the experiment from analog signals and network and measurement lab, which is developed by IIT Kharagpur. So again, you have the objective provided here is mainly to this laboratory can be broadly divided into 3 types, which is basic electrical technology laboratory. Experiment under this section are related to verification of different network theorems used in both DC and AC circuits, and also signals and network laboratory, where students will be performing experiments related to properties of various analog signals and network. And the third one is electrical electronics instrumentation and computer science engineering, which is measurement laboratory, where the students will be experimenting under the sections which are related to measurement of different unknown electrical components like capacitance, inductance, power measurements, etc. So let's move on to list of experiments. Yeah, so this is mainly used this lab demonstrative regarding the different types of theorem, and we have around 28 experiments available under this laboratory, which is analog signals network and measurement laboratory, which is under electrical engineering domain. So which are some of the basic or main theorems, which is Norton, Thevenin superposition, Millman, Teligans, etc. So, and also RLC circuit analysis, maximum power transfer theorem verification, and all are provided under this laboratory. So next, let's move on to first experiment. Yeah, again, I repeat the same things, which are aim, theory, pretest, procedure are the flow or the common field available under each of the experiment. So let's see the theory part. So mainly in this theory part, the verification of Norton theorem is described where a linear active network consisting of independent and dependent voltage and current sources and linear bilateral network elements can be replaced by an equivalent circuit consisting of a current source in parallel with the resistance. So we have the circuit with the source Vs and load RL provided, and the equations for this or defining the Norton theorem is provided under the theory part. So again, you have the procedure or pretest section, procedure section. Yeah, you have the procedure where the experimental setup or the circuit diagram is provided, and also the step-by-step procedure is mentioned here with the equations under the procedure section. So moving on to the simulation. you have the verification of Norton theorem simulator interface provided here, and we have the procedure provided under the left side of this simulator interface, where for this experiment you have 4 cases. So let's see each cases, and what you need to do in each cases is provided here under the experimental part select. One, we have to select, here you have this S1 and S2 option, and you can select S1 as power, short or intermediate. Similarly for S2 also you have 3 more options which states power, load and short. So to observe the load current, you have to select the S1 to power and S2 to load, and just if you go down you will be getting the circuit analysis to determine load current, and you have to select the load current. To get the load current, select switches S1 to power and S2 to load, and once you select the S1 to power and S2 to load, just click on to the simulate button, where you will be getting the load current data. So second case is mainly describes about the Norton short circuit current analysis, where we have to apply S1 to short and S2 to the power. Sorry. S2 to power, and just here you have to move on to the case 2. Yeah, to determine Norton short circuit current ISC, you have to change this or select the switches to short and power. And once you select or changes the switches, you will be getting the Norton short circuit current ISC. Similarly, again, 2 more cases are there where you have to where you can observe the Norton resistance analysis and also to determine the load current. So we'll try that also. Move on to the case 2B, select S1 to short and S2 to power. So you'll be getting this Norton resistance analysis. Once you click onto that, you will be getting the V2 current and Norton resistance RN, okay, which is 216.67 ohm. Similarly, the case 3, which is using ISC and RN, determine the load current. So let's select the case 3, and you have to change or the where there will be comparing of this. So once you click onto the simulate button, you will be getting the load current, and if you click onto the fill data to the table, the observation table is updated, and once you change the resistance and voltage sources value to take another observation, so you can change it and take another observations. Okay, so you have the observation table here, and once you get the sufficient values, you can just click here to print option, so it will be printed, or you can save it as PDF for the future reference. So the complete page of the simulation will be printed with the observation table, or you can save it as PDF for the future reference. So here you have to just change the resistance value and get the load current in the observation table. Yeah. So that is one of the experiment available under Analog Signals Network and Measurement Lab. So once you complete the simulation, you can move to the post-test references, and the contributors from this list or this experiments are mainly from IIT Kharagpur. So the email ID and the institute, the developer name, and also the department and the web page, everything is provided here. Yeah. And finally, there is a feedback section. Yeah. So that's about one of the experiment, which is verification of Norton theorem, available under Analog Signals Network Measurement Laboratory. Again, let's see some of the experiments from control engineering and so on. So if you move down, you will be getting again a few more new labs, which are optical communication lab, microwave engineering, industrial electric drives, which is developed by NITK Surathkal. So let's see the industrial electric drives lab developed by NITK Surathkal. Yeah, so if you go to this laboratory, again the field are common. If I move on to list of experiments, and if I select Yeah, I'll go with introduction to ladder logic experiment. So here for this experiment, we are mainly implementing basic logic gate functions using PLC. So the other thing from when we compared with the other experiments, the main thing you can note it down here is instead of pre-test and post-test questions, you might be getting self-evaluations, and also there will be quiz questions and also assignment questions. And again, you can see a main part which is videos. So let's move on to that. Before that, you have the theory, detailed theory provided here, which is mainly to introduction to logic or ladder logic. So you can just go through this theory part to know more about ladder logic and so on. And also we have the procedure and a self evaluation. Again, some of the MCQ questions are provided. So you can just select the answers and get the right and wrong answers. Simulation. So I'll go with the AND logic implementation using PLC. So here in this experiment, you will be getting the logic implementation using PLC for AND gate, and different conditions are provided. Truth table of AND gate is provided here. So if you click onto any of the condition, it will be applied here and you will be getting the output. So here in this experiment, both the switches are off and the light or the bulb does not glow. Where both the switches are off, it is 0 0 and the light is 0 or output is 0 where it is de-energized. So let's go with the fourth option where both the switches are on. So once both the switches are on, you can see it is energized and the bulb starts to glow. So it is noted here through animations, and once it is both the switches are on, you will be getting energized and the bulb here starts to glow. So moving back, again in the second or third condition where one of the switch is on and the other is off, again it is de-energized condition and the bulb does not glow here. So that is one of the experiment available under Industrial Electric Drives Lab. Similarly, you have apart from AND logic implementation, you have NAND logic, NOT logic, or NOR, XOR, and XNOR logic implementations using PLC. For the common concept, you can just go through this laboratory as well, which is Industrial Electric Drive Lab, and the experiment name is Introduction to Ladder Logic. So again, let's see one of the experiment from Control Engineering Lab. Yeah. So these control engineering, microwave engineering, and all are common concepts and like recent concepts for students who are doing their BTech. So here you have again you have the introduction, objective, list of experiments, and so on. So let's see one of the experiment. Maybe we'll go with the first order unity feedback experiment, where it is mainly to determine the step response of first order transfer function and also to determine the impulse response of first order transfer function. So again, the detailed theory of first order unity feedback system, unit step, and so on are provided here under the theory. You have the pretest questions. So in the procedure, let's see the procedure or the step-by-step procedure are provided here to determine step response of first order and to determine the impulse response of first order system. So moving on to the simulation. Yeah, we have the simulator interface. Here you have the option to select the determine the step response or impulse response of first order system. So once you select that, you can change the user inputs or also the denominator polynomials of coefficients of denominator polynomials. And once you click onto the submit button, in the command window, you will be getting open loop transfer equations, closed loop transfer equations, and a step response. And once you click onto the run button, you will be getting the equations for open loop transfer equations, where for what you have selected the user inputs. And again, if you click onto the run button, you will be getting the closed loop transfer equation and also the step response. And once you get the step response, it will be plotted here. Okay. And in the conclusion, Also, the conclusion is noted down here. Similarly, the second option is to determine the impulse response of the first order system. Again, you have to select the user input and the denominator values and submit. In the command window, you will be again getting the loop transfer function, closed loop transfer function, and impulse response graph. Just run. You will be getting the open loop transfer function based on the values we selected, closed loop transfer function, and the impulse response graph and the values. Yeah. So that is one of the experiment which is under control engineering lab, which is first order unity feedback system. So once you complete the simulation, go through post test, references, contributors, and feedback. Yeah. So yeah, we have showed you around 8 to 9 experiments now. Now maybe I'll be taking you to optical communication lab, which is developed by IIT Roorkee, which is again a new lab. So again, if you go to the optical communication lab, you will be having the objective of the optical communication lab is to mainly to understand the structure and applications of optical fiber. And under the list of experiments, you will be getting around 8 experiments, mainly of characterization of LED, laser diode, intensity modulation of laser output through an optical fiber, measurement of data rate for digital optical link, numerical aperture, losses in plastic fiber, APD, optical power measurement, and so on are the list of experiments. And target audience, mainly this lab is applicable for fourth year UG from electrical engineering or electronics and communication engineering, course alignment, and a feedback. Yeah, so this under course alignment, mainly 3 universities are mentioned. So let's move on to the list of experiment and we'll go with the first experiment. So the aim of the experiment is to study the characteristics of LED and plot the graph of VI characteristics of LED in forward bias condition. So if you move on to the theory, you will be getting detailed theory. What does an LED means? Mainly the LED is a semiconductor diode that emits light when an electric current is applied in forward direction of the device, as in simple LED circuit. So you have the LED circuit here. 2 basic LED configurations being used for fiber optics are surface emitters and edge emitters are provided. And also the circuit diagram or setup for characterization of LED is provided. So you can just go to pre-test, post-test procedure and so on. And now we'll move on to the simulation part. So this procedure mainly here is to connect the circuit, apply supply voltage from DC regulated power supply V in from 0 volt to 10 volt, tabulate the readings by measuring in the voltage VF across the diode and current IF through the diode for different steps for applied voltage, and finally you can plot the graph between voltage across the diode and current passing through the diode. So let's see the simulator. Here you have to just drag and connect it. You will be getting the instruction how to connect it. But here you can see the same color and see you can connect it here. It's simple. Once the connection is complete, just click on to check. So you got a pop-up stating if the connection is right. So once the connection is right, you can just click on to the start button. So where you will be moving into the other page where you have the control section, circuit, and an experimental reading table. So you have to on the power, select an LED color. You can select any of the LED color, change the resistance, select the V in, just click on to, so once you click the V in, you will be getting in the experimental reading table that the applied voltage, LED voltage, and the LED current is noted down. Also in the circuit diagram, the values will be updated. So it is, if it goes beyond, you can see the LED damaged. Okay, you will be getting a pop-up message. And once you get the sufficient value, just click on to plot button. You will be getting the plot, and also you can print it. So here you have the printing option. For mainly for all the labs and experiment, you will be getting a printing option. So that's it. Yeah. Maybe you can click onto the reset option to to reset the complete values, and you can start the restart the experiment by selecting the resistance and input voltage. So that is one of the experiment from optical communication lab under electrical engineering domain. So once you complete the simulation, try with post test and all references, contributors, feedback. So again, if you move on to electrical engineering domain, you have labs from microwave engineering, substation automation, again, which is a lab developed by NITK Surathkal. If you go to industrial electric drive lab, once you complete the simulation, you'll be getting assignment questions, quiz questions, and a video which is named as Lakupata video, where you will be having detail about how to do the simulation, both the physical as well as the simulated video is provided here under the video part, so you can refer to that as well, as which will help you to complete the simulation easily. So this for most of the labs developed by NITK Surathkal, you will be getting a video part also, where you will be getting the video of the physical experiment as well as the simulation related experiments. So you can just refer to that to complete the simulation. So yeah, that's all from my end. You can just go through other experiments and labs available under electronics and communication and electrical engineering domain. So thank you all. And now I'll be handing over to Shrestha, who will be taking you to other experiments and labs available under website. So thank you all, and over to you, Shrestha.
Hope it's clear. Uh,
Yeah, maybe I'll just show you one of the experiment from microwave engineering. Then Shrestha will be taking over. So I hope my voice is audible, and I'll be sharing my screen, and I hope it is The screen is also visible for all of you. So to get the microwave engineering lab, the flow is same. You have to just go to electrical engineering domain, click on to microwave engineering lab. So again, you will be having the introduction, objective, list of experiment, and so on. So the objective of this microwave engineering lab is to mainly understand the microwave waveguides, passive and active devices, tubes and network analysis, and also to handle microwave equipments, and also to measure or for the concept of microwave measurements. So again, if you move on to the list of experiments, you'll be having different experiments like familiarization with microwave laboratory apparatus. If you go through that, you can see many of the apparatus mainly used for microwave laboratory in the microwave laboratory. So it's similar to electrical machines laboratory. You'll be getting name of the equipment, simple, and the function. Just familiarize it, and you can move to the next part. Sorry. You can move to the next part. Similarly, other experiments under microwave engineering lab are study the characteristics of repellent klystron, gun diode, VI char of gun diode, and so on. I'll go with the gun diode, VI characteristics of gun diode experiment. So if you click onto that, you will be getting this simulator interface. You will be having the instructions provided here. Again, if you move down, you will be getting the components list and all. So you have to just click onto the components list, and again in the side you will be getting the list of components, and you have to select it and drag it to the simulator interface. For that, you will be getting an experimental setup button here. So you have to just drag and place it over here. So if you are moving the right thing, you will be getting a pop-up message as right, or else you will be getting the option as wrong. So I'll just see the procedure here. Yeah, you have the experimental setup provided here. You have to just drag and drop it in the correct places. So I'll just drag and drop it in the correct places here. Yeah. So once you have taken it from the component list, it will be empty here, and you have to drag it in the correct places. Yeah. Just drag and place it here. For the connection, you can refer on to the experimental setup and the pin modulator. Finally, the pin modulator is also. Yeah. Now we have to do the connection. So from pin supply, gun supply to pin modulator, and from here to detector. Yeah. So once it is done, you can just switch on the button to get the gun supply. And there is some corrections required. Yeah. Select the pin bias, a gun bias condition, and here you have some option to options to add it. Actually, I'm not getting it properly here. So once you complete the connection, you have to select the gun bias and you have to toggle this, and you will be getting the output. For more, you can see these instructions actually under microwave engineering lab. Yeah, once you complete the connection, move the gun bias knob and set it into 0.5 or above the recording of your readings. Then you can toggle the switch button to get the value of gun diode by current. Similarly, if you click on to add to table, take down the values of gun bias voltage and gun diode current. You can proceed this for almost 7 readings. And once you click onto the plot button, you will be getting a graph. And if you want to save it as, you can just click onto the save button. So that is here mainly you have to just drag and drop the components here, complete the connection on this power, select the gun bias, toggle switches, and note down the values in the experimental table. Once you get around 7 readings, you can just plot it. So the flow will be same. If you have more doubt, you can just go to the procedure section where they will be giving you all the step-by-step procedure to complete the simulation. I hope I hope you understood the flow. So yeah, that's all from my end. Thank you and all, and over to Shrestha.
Yeah, thank you, Vismaya. I hope my voice is clear and audible. Yes, so there is some glitch in my system. So let me continue presentation from the same system. So very good morning to Ananda presenter here again. You have seen a couple of demonstrations from circuit domain labs, right? So let me take you through with some more labs under circuit domain, labs and experiments under circuit domain. So we'll see some more different variety of simulator interfaces that we come across. Okay, so let me share my screen now. So hope my screen is also visible. Yeah, so we'll go back to the main website of virtual labs. So it is same vlab.co.in. Okay. Yeah, so this is the website of virtual labs. So let me start again with electronics and communication domain. Already we have seen few of the labs. So we'll get into few more labs from the same domain. So as I told, so you have seen at that time, first lab experiment. So I'll go with the second lab, analog and digital electronics. Second, from again IIT Roorkee. So the structure is very similar with the lab and experiment. So maybe we'll directly go to the simulations so that you can explore other sections later. Okay. So here, if we see the list of experiments, under this lab, we have around 8 experiments, which are mainly of op-amp and 555 timer based. So if we take one of the experiment, the flow is somewhat similar to what you saw with familiarization of IC. Okay. So here the experiment is mainly mathematical operations using op-amp. So these are the 3 operations which simulation have. We have again a theory section, set of questions available under pre-test and post-test section, procedure tab, reference links, contributors name, and the feedback link. So procedure, as Vismaya already told, it is procedure to perform experiment in this particular virtual labs platform, and simulation is where we can actually perform the experiment. Okay. So here if we see, we need to first select operations which we need to perform. So I'll go with addition, the first option. Okay, so once operation is selected, we'll get list of components. So we'll get all the components to work area. So we need to click on each of the components. Okay, so now we have all the components in place. So next step is we'll see the instruction. We need to connect the components as per the circuit diagram provided in the instruction. Okay, so this is, we know circuit diagram. So quickly we'll do the connection. So first power supply. So we'll connect 15. Yes, just give me a second. Yes. So we'll connect all the grounds. Okay, so it is giving some issues with the connection. Let me try. If not, we'll go with the other experiments. So basically, we need to connect all the components as per the instruction provided. Okay, so now we need to connect resistors. So connecting each of the resistors to the supply. Now I need to connect other end of resistors all to one point. So finally, yes. So to the op amp. So RF I'm connecting to terminal 6. Then to ground. 4 to minus 15, 7 to plus 15. Okay. Now finally the multimeter. So ground and to 6. Yes, 4 connections are right. Yes, so we got a pop-up message stating connection successful. So next step as per the instruction is to click on show output. Okay, so once we click on show output, we'll get readings within the circuit, that is in multimeter, the output will be visible also with the supplies. If we need to tabulate it, we can click add to table. Okay, so current calculated output value is 0. No inputs provided. So I'll click OK. So we got readings tabulated. Now we can provide input voltages. So we have sliders provided here. So we can provide values for each of the voltage. And now if I click on show output, we'll get the experimental reading in the multimeter. Now if I click add to table, I need to calculate the theoretical value. It is 0.3 plus 0.2 plus 0.2. So 0.7, but it is minus 0.7. So if I click OK, so correct calculation, and we can see table getting updated with the theoretical as well as experimental reading, and also we'll get percentage error between theoretical and experimental readings. So likewise, we can give multiple values for V1, V2 and V3, and we can tabulate all the readings. Okay, so this is one of the experiment under the second lab under electronics and communication domain. That is, I have chosen experiment from analog and digital electronics lab new. So similar flow, but the application. You can explore other experiments. So it will follow a similar flow. So this I have chosen for addition experiment. Okay. So now I can go back. So if I click the reset option, we will get again option to select other operations from the same experiment. If I need to go back to the other experiments, I can just go back, select other experiments from the list. Okay, so this is one of the experiments from this lab. So we'll explore other labs now because other experiments will follow a similar flow. So moving to the next lab, Analog Electronic Circuits Virtual Lab from IIT Kharagpur. If we look into the experiment list, here we have again 7 experiments. Okay, so I'll just take you through first experiment. It is very basic, familiarization with oscilloscope and function generator. But if you see the simulation, here we have simplified interface for function generators and oscilloscope. So similar oscilloscope have been implemented with the experiments of basic electronics lab. So Vismaya at that time had shown Ohm's law experiment, right? That doesn't had any oscilloscopes in it. But if you explore half wave rectifier or basically rectification experiments and all, you will have simplified oscilloscope with similar interface. Okay, so we need to connect function generators to oscilloscope. So as per the instructions, it is connecting oscilloscope and function generators. So channel 1, okay, so finally the ground connections. Next step as per the instruction is to check if the connection is right or wrong. So we have check button. We got a pop-up stating it is wrong. We have loops here. So for that, if we click on node names in some of the experiments, connections made for that particular node only will be removed. If not, we have option called delete all connection. So we can quickly reconnect. So we got a pop-up message stating right connection. So next we need to turn on the experiment as per the instructions. If you see the 7th instruction, click the on button to start the experiment. Okay, so here is the on button. So we need to click that. Once we click, we'll get XY axis on the oscilloscope window. And next is to provide inputs. So here we can see different types of inputs. So I'll select sine wave. Okay, we can see sine wave being displayed on the oscilloscope window. So I'll give channel 2 as well. Now we have different options here. We can select channel 1 or channel 2 output to be visible. We can make both the signals to be ground, or we can click on dual option to see both the waveforms, and we can adjust the position. Okay, so we can adjust position of both the waveforms. We can adjust X origin position as well, X-axis position as well. So other controls are very similar to our CRO, but this is simplified one. Okay, so I can change the frequency of each of the waveform. I can change the amplitude. Okay, then I can change voltage volt per division as well. So these are the controls what is available for this particular experiment and the function generator and CRO as well. So similarly, we can observe other waveforms. Okay, so as per the instruction, these are the steps. So if you explore, I go back. If you explore basic electronics lab rectifier based experiments, you'll get similar type of interface. And if you want tutorial on oscilloscope, simplified oscilloscope, it is available here under one of the section. So basically I have moved to same experiment. Okay, familiarization with oscilloscope and function generator experiment. Here if you see the subsections available along with other subsections, we have another one called oscilloscope tutorial. So basically simplified oscilloscope tutorial is available here. So this is about that particular experiment and experiments under that lab. Now, if I go with the next lab, analog electronics lab, for example, here, if you see the experiment list, we have around 7 experiments. The difference here is we have circuit fixed here. Okay, so if I want to take you through multi-vibrator experiment, we have same experiments available under multiple labs with different simulator interfaces. So we'll take one from this lab. Other subsections are very similar: aim, theory, retest, and post-test questions with set of questions, MCQ based. We have reference links and feedback link. Then the simulation. So here if you see, if I take one of the multi-vibrator, I selected monostable. We need to complete the connection first as per the instruction provided. Okay, so here we have node names and also color indication. So I'll connect. Okay, so we have connected all the things as per the instructions. These 4 connections we have made. So next step is to check if the connections are right. So we have option called check connections button. So once we got a pop-up stating connection is correct and we can proceed with the experiment, we can click on the start button. Okay, this is how the simulator interface available for monostable multi-vibrator experiments of analog electronics lab. So we have here control. So first we need to turn on. Again, I'm following the instruction. Okay, so use toggles on off button to provide power supply to the circuit. Next is we need to use resistance range slider to vary resistance values. We can plot the graph for different set of R values. Okay, so first turn on the toggle switch. Now this is enabled once we turn on the power. Next is I need to vary the slider for resistance. Once I provide here value for R, readings will be tabulated. We can click on plot button to get graph for this particular reading. Okay, we will get graph of trigger input, voltage across the capacitor, and also output voltage. So we can observe when the trigger input has moved from high to low, we got output VC as well as the output voltage. Similarly, we can observe different graphs for different values of R. So I have increased the value of resistance. I'll plot the graph. You can see the expansion with the graph. So I'll take one more reading. I'll click the plot button. So this is the graph what we have obtained. So we have print option as well. So clicking on that, we can save entire simulation interface in PDF format. Okay. So this along with the date and time, we can save it for a future reference, or this could be asked from students as part of assignment submissions as well. Okay. That is regarding experiments from analog electronics lab. So if I go back, you can see other experiments from the list with similar interface. Okay, so we'll go back. We can, you have already gone through basic electronics lab. We have 16 more experiments under that lab, which I hope you can explore. Below, we have a couple of experiments, couple of labs actually for the concepts of digital electronics. Okay, so we'll see one or two. Maybe I'll take you with hybrid electronics lab first. It's from COEP Pune. Okay, so this is one of the basic lab for digital electronic concepts. So we'll go to the list of experiments. We have around 7 experiments, one of the older lab. Okay. So if we select one of the experiment, it is just to understand the concept. Okay, no much hands-on here. So again, other subsections provided. So I'll directly go to simulation. So we have aim section, theory, couple of questions available under pre-test and post-test. We have reference links, feedback link, procedure tab with procedure to perform experiment in this virtual labs platform. Okay, and the simulation interface. So this is how is the simulation interface to basically implementation of different arithmetic circuits. So under adder, we have 3 options: half adder, full adder, and 2-bit adder. Again, under subtractor, we have 2 options. Finally, we have 4-bit adder subtractor. Okay, so how to proceed? It is very simple. So first select which type of arithmetic circuit you want to see or demonstrate. So if I need to go for full adder, we can select that. We have truth table already available. Only thing is we can provide inputs here. So I will provide input. Say if I give 1 0 and if I give carry input, next step is to click the run button to observe output. So for 101 condition, we got carry 1 and some output as 0. Okay, so it's very basic, but we can utilize it for understanding the concepts. Similarly, if we go for 2-bit adder subtractor or 4-bit adder subtractor experiment, suppose if we give this experiment as part of assignment, then students can come over here, verify first, they can solve using pen and paper and verify their results coming to this platform. They can provide input values of A and B, the random examples I'm giving. Okay, so now they can click the run button and observe the output. So they can basically verify if their theoretical answers are matching this. Okay, so this is one of the very basic lab available for the concepts of digital electronics. Again, as I told, each of the divisions can be observed. So other experiments will follow a similar flow. We have different code converter based experiments. We have experiments to simulate all these concepts, decoders, encoders, multiplexers. Okay, so all these are simulated under this particular lab. So if we go and look into some other lab, maybe I'll take you through one of the lab from IIT Roorkee, Digital Electronics Lab 1. So here, if we see the experiments, we have around 12 experiments. Some of the experiments which we saw in the previous lab are also available over here with a different simulator interface. Maybe we'll see one of the sequential based or yeah. So maybe we'll see verify the truth table of different flip-flops. Okay, so I have selected the 6th experiment in the list. We have similar subsections. So if I go to simulation, we can choose one of the flip-flop. Maybe I'll go with the first option. Yes, so this is how the simulator interface is. Here the circuit is fixed. We need not connect any of the components. We have instructions. So first is we need to connect the supply. Then we need to provide input. Then we need to apply clock. Then we can tabulate and note down the graph, observe the graph as well for different inputs. Okay, so this is the flow. Here we have a couple of switches to provide the input. This is the circuit diagram already connected. Below we have truth table and here is the clock diagram to observe. So as per the instruction, first is we need to turn on the supply. Okay, now we need to provide input through switch. So if I want to implement set condition, I'll make S as 1. I'll keep R in 0 state. Now we have not observed any change in the output. For the output to change, we need to apply clock. So we have switch to apply clock. So once I apply clock, you can observe output reflecting in the LED. Now if I want to tabulate the same thing, I need to click add button. Clicking on that, we can tabulate the readings. So once we click add button, clock and inputs will be reset back to 0. Now we can apply other combinations of input and tabulate the readings. So if I want to implement reset condition, I'll make R as 1. I'll apply the clock. Now Q bar has turned 1. Q is in 0 state, that is reset condition. I can tabulate it by clicking add button. You can see simultaneous updation in clock diagram as well. Similarly, 0 condition and 1. Okay. So finally, we have print option. using which we can save entire simulation interface in PDF format. Again, this could be used for future reference or as part of submissions. Okay. So that's it. This is how it is. We can observe implementation of other flip-flops. It would be in a similar way, and we can explore other experiments as well. Okay, so we have many more labs which you can explore. So we'll go with one more lab, digital signal processing from IIT Kharagpur. So this is one of the signal processing based lab already available in the platform. Okay, so again, we go to list of experiments. We have around 10 experiments. So we'll go with the first one, study of sampling theorem, and see how different is the interface. Okay, so basically it is study of sampling and also effect of undersampling. So detailed theory is available in theory section as what we observed with the other labs as well. Again, questions under pre-test and post-test. Procedure to perform experiment in this virtual labs platform. Okay. Then we have simulation where we can perform the experiment, reference links, contributors list, and the feedback link. So this is again one of the older lab, but earlier experiments of this particular lab were flash based. Okay, so since currently flash is blocked by the browser, all the experiments have been converted to non-flash based. Okay, so this is how it is. These are the instructions. So we have block diagram already available over here. So we have signal generator, sampling block, and virtual scope. So this is to provide input. This is to sample the input. So using virtual scope, we can observe the waveforms and different conditions of sampling. Okay, so basically we can observe both input signal and sampled signal. So that is the block diagram. Next, we need to select amplitude, signal frequency, input signal frequency, and sampling frequency. So for that, once we turn on the power, we will get function generator controls using which we can provide all these three, that is amplitude, input signal frequency, and sampling frequency. Next, we need to click on channel 1, channel 2, or dual option to observe the corresponding output waveforms. And then we can change values of the input controls and observe the output signal variation. Okay, so here are few notes. The main thing we need to know is the third one. So to change the values, we need to just scroll by hovering on the knob. Okay, so I'll go down. First, we'll provide the inputs. Okay, I'll click on dual option first. So this is for the default value that is being set in the function generated controls. I can change the oscilloscope controls here. Okay. So as per the note, they told to maintain time. I'm just following the last variation, time per division, to keep it same for both the channels so that it will be easy for analysis. Okay, so I have kept the value as 4 and just scrolling by hovering mouse on the controls. Okay, so now we can change the amplitude, we can change the frequency, input signal frequency, and we can change the sampling frequency and observe different cases of sampling. Okay, So we know as per the sampling theorem, more the sampling frequency, easier to reconstruct the signal, right? So now my signal frequency is 3 kilohertz. Yes, you can observe here, signal frequency is 3 kilohertz, sampling frequency is 20 kilohertz, and this is the input amplitude, signal amplitude. Okay, so with this we can observe different cases of sampling by changing the sampling frequency. So I'm reducing the sampling frequency, number of samples will go down, which will make one to reconstruct the signal difficult. Okay, so this is how sampling theorem experiment being explained using virtual labs platform. So likewise, we have other experiments as well again. Okay, so there are 9 more experiments which you can explore. So other than that, we have a couple of labs for analog and digital electronics, which I request you to explore. I'll just move out from the labs under electronics and communication. So we were telling from the beginning and from previous days as well, when you are looking for concept of your interest, you need to look into relative domain labs and experiments as well, right? So as an example, again, I'll take you to computer science and engineering domain, and we'll see where exactly is circuit domain concepts available. Okay, so we'll go into computer science and engineering. You can see a couple of labs that we saw yesterday, which are core to computer science and engineering. Whereas, if, for example, if I want to take you through computer organization and architecture lab from IIT Kharagpur, and if we observe the list of experiments, you can see here most of the experiments are relevant to circuit domain as well. And for example, K-map, which is one of the basic concept for digital electronics, the experiment for this is available only under this particular lab under computer science and engineering. Okay, so if we quickly see the interface, okay, so here if we quickly see the simulation, this is how it is. So we can click on the simulator. Yes, so this is K-map simulator available. So we can have up to 8 variable K-map. Okay, so if one wants to implement 5 or 4 variable K-map, 4 it is already given. So if I go with 6 variable K-map, we can get the cells. Now we can take a random example for better exercise, or first I can hide result, take a random example, solve it using pen and paper, and unhide the result to check the grouping and read for the reduced expression. Okay, also if we want to manually set any of the cell value, then I can click on each of the cell. I can have don't care as well available. So I'll make don't care, allow don't care as S. Now if I want to have 1, I'll click once on the cell. If I want to have don't care, I'll click twice on that particular cell. Okay. So this is how we can see the grouping and the reduced expression. So as I told, we can have any variable K-map. We can have don't cares as well. We can hide the result initially and unhide whenever required to check the grouping and reduced expression. Okay, so this is K-map simulator. Experiment is available only under this particular lab, that is Computer Organization and Architecture Lab, available under Computer Science and Engineering domain. So other than that, we have again other labs with relevant, few of the concepts relevant to circuit domain. Okay, so similarly, if we go back and see electrical engineering domain, so few labs we have already seen. Ismail has taken you through some of the labs. So if we look into some more labs, which could be useful for both electronics, electrical, or physical sciences domain. So here there is one new lab, electrical measurements lab from IIT Roorkee. So if you observe here, we have a couple of experiments in it, 10 experiments. So first one, if we see, it is very theoretical based experiment, but which provides sufficient of information on different measuring instruments. So if I click on simulation, so we'll get familiarization with different measurement instruments. So we just need to click on next. Okay, so different slides will come up with each slide for different types of measuring instruments. Okay, so we'll get detailing information on each of these. So likewise, we have other. So just I'm showing you to take you through different types of interfaces that could be available with the virtual labs platform. Okay, so this is of measuring instruments experiment. We have other experiments as well with under that lab, and we have a couple of labs for electrical machines. We have a couple of labs for power electronics. So if we quickly look into one of them, power electronics lab from IIT Delhi. So we have set of experiments under each of the lab. Okay, so this lab again have 10 experiments. So if we quickly look into one of them, it provides detailed information on what are these, their workings, and also the characteristics. Okay, so with the first experiment, we can see SCR, detailing on SCR. IGBT and MOSFETs is loading. Performance characteristics of these three. So we'll quickly see the simulation, how it is. Okay, so these sections are covered. Okay, so we can see here, we can click this button to see each of the slides. Okay. If you want to skip this, so it provides step-by-step explanation on each of the concepts. Okay, so first starting with MOSFETs. So detailed information is provided. So like that, we have around 11 slides. If we want to skip them, we can just drag this. Okay, so then we have detailing on SCR and IGBT. Yes, this is how it is. Next, we have next option, which we can click. Now we can select the device. Okay, I'll just select. So select the method of plotting via characteristics. We can select one of the option. Okay. We can turn on the mic as well. Indicated with the arrow mark, we can just go on clicking each of them. So we have components in place. We manually need not connect. If we click on each of the options, it will be connected. We can just observe the connections. Okay. So once that is done, we can click on connections completed. We can switch on the main supply. We can start the experiment. Okay. So we can proceed with each of the experiment. Now we have already plotted it. So we can directly click on the download option. Okay. Yes, we can click on if we click on download, the simulation interface will be downloaded. Okay. If we click on next button, we'll be allowed to select the other options as well. Here some zoom controls have been selected, so I am not able to click any of these. So if not, this is how it works. So we can proceed with, so here we have reached up to 4 steps. We have 2 more to complete the experiments. Okay, so we can click next. So we can click on the second options as well. Similarly, it will go. And just clicking on the options. So connections completed. I can turn on, start the experiment. So click on the gate resistance. So basically it is indicating with the arrow. We can select each of the, we can click on that each of the time. We can get a message what it is also displayed here. So once we proceed as per the instructions, once we complete each of the steps, then we'll get an experimental result which we can download and save it. Okay, so this is how the flow for the experiments under power electronics lab. We have couple of experiments available under 3 of the labs. Okay, so quickly see. Yes, so the conclusion will be available as a text over here. Also, we can download. Okay, so by clicking on download button, we can save the entire simulation window in PDF format. If we click on next option, we can see input output waveforms. Okay, so these are the steps as per the instruction, step-by-step instruction that will be provided. We can proceed. So yeah, so we can explore other labs as well. So these are few of the major labs available from the listings. Similarly, we have a couple of concepts available under physical science domains as well, relevant for all the circuit as well as physical sciences domain. So I think since we are nearing the time as well, I can stop the presentation from my end. I'll stop sharing my screen. So maybe we can have quickly, if we have any queries from the participants. It is open now. You can type in the chat box.
Yeah, participants, if you have any questions, you can please use the hand raise option, or you can type your question in the chat box. Meanwhile, as you ask the questions, the feedback link has been posted in the chat. I request all of you to fill the feedback form. If you have any questions, yes, sir. Yes, we will share all the recordings of the sessions once the FDP is finished, along with the certificates.
So today we have shown a couple of experiments, maybe 1 or 2 experiments from many of the labs. There are many more you can explore. So if you have any queries, you can always get back to us. Our team will be always ready to help you out. Or you can provide your feedback or concerns through feedback link provided as well. So each lab and experiment will have feedback. So through that as well, you can contact the respective teams.
All right, I think if we do not have any questions, we can close the session.
Yes, sir. Yeah.
But thank you, ma'am. Thank you, Mr. Viswa ma'am and Shrestha ma'am for the wonderful session today. So tomorrow we'll be meeting again for the 4th day. Tomorrow we'll be having the demonstration of the virtual labs on core engineering and chemical sciences. So that's core engineering and chemical sciences for tomorrow. So I request all of you all to please join tomorrow's session as well. So until then, if you have any questions, ma'am will be there if you can ask questions. Otherwise, you can fill the feedback link and we can close the meeting.
Yes. Thank you, sir.
Thank you, ma'am. Thank you, everybody. Thank you for joining today. We'll see you all tomorrow for the next session on core engineering disciplines and chemical sciences, demonstration of the virtual labs. Thank you, everyone. Have a great day. Please fill the feedback link which has been posted.